Okay, hello and welcome back to Mr. Nice Guy tutorial in Hyperwork 2017. Today we are going to make a crash simulation using Radios. So, first of all, open up your Hypermesh and then when prompted at the user profile, change it to Radios and click OK. So first thing that we're going to do in this simulation is to make the component what is going to crash into what. So there is two ways to do this. The first way is to make the node and line and manually meshing all those components, and the second way is to import the geometry. But for this simulation we are going to just import it because it is more easier than to make manually. So go to file, import and geometry. Okay, as you can see here I have my file already load, so I'm going to clear them and then click here to find your file. Make sure your part file is in IGS, so click both of them, open and then import. Okay, then you're going to see something like this. Go back to your model and change the view. Okay, to change the position, go to tools and translate. Okay, we are going to move the component, so if you have something other than component here, you can change it here. Go to component and then you are going to move this box in the X direction. So click the component. We are going to move the second one, which is the solid box, and the tube is 300, so we're going to move it 305 and translate. So let's see. Okay, we have a gap of 5 mm here, then change it in the Z direction, 5 mm, adjust it. Okay, then top view in the Y direction, move it a little bit. Okay, so you should have something that look like this. Okay, so we're done here. Open up your component, change the name into box frame, and the other one is tube frame. Okay, now we are going to make the skin, the mesh of the component. Right click, create, put a name first, which is the tube. Let's do the tube first. Tube, aluminium tube. So hide the box frame first. You don't need. Okay, go to 2D, auto mesh. As you can see here, it is hard to see which is the side. So click here and here. Okay, highlight the part that you need. Side, this side and this side. Okay, before you mesh it, change first element to current component because we want the mesh to go to the aluminium tube component. So change this to current component because the current component is the aluminium tube. Click mesh and mesh. Okay, return. Your box should be yellow as according to your component, aluminium tube yellow. So you can hide the frame tube now. Okay, so you can see we have the tube already made. So create another component for the box. Okay, now you can hide the tube first and show back the frame. Okay, for the solid box we are going to go to 3D tetra mesh, change the 2D type into R3S, keep every volume tetra. Keep everything as default and change the element size into 15. Okay, click the solid box and mesh. Okay, the box should be the same color as your component. Okay, so we can return. So now we have both the solid box and the aluminum tube, so we can go ahead and delete both of this part. Okay, we don't need it anymore. Okay, so we have the component already made, so let's follow the step. Import geometry done, component done. Now let's make the material. Go to the material, put it aluminum, go to elastic, cut image into, oh no, not elastic, elastoplastic. Find M2 0, click. Okay, create edit, and then you should put your value here. So I have a list of table of material properties right here, and we are going to make aluminium 0.7 0.7 E5 for the young modulus, and U is the Poisson ratio, which is 0.35. I think it is aluminum alloy, 0.33. This is 0.75. Row initial, which is the density, is 2.79, 2.79 E negative 9. And let's keep the other as default. Then we're going to make steel component. Change the type into elastic. Cut image is M1. Create edit. Highlight all these three components. Steel is 2.1 E5. 2.1 E5. Poisson ratio is 0.3. Row initial is 7.89. 7.89 E minus 9. Okay, return, and you should have two material here. Then we're going to proceed to properties. So now we're going to make the tube properties first. Tube properties, and the type is surface. Cut image is P1. Put the thickness 5. Create edit, and scroll down, find N, change it to 5. Okay, return. Next one is steel properties. Change the type into volume, and cut image is P14 solid. Create edit. Here we are going to change I solid here into 24. Okay, return. Okay, now you have two material and two properties. Two component, two material, and two properties. So the next step is to load collector. Okay, load collector. We're going to make velocity first. Call it velocity. The cut image is INI. Initial velocity, inival collector. Create edit. This going to change in the X direction, so velocity in the X direction should be minus 5000 for 5 meter per second. And return. Next is for the mass. No, velocity. Let's put it mass. Card image to BCS collector. Create edit. Okay, here we are going to limit the movement of the velocity into just X direction. So tick all the other motion except for in the X direction. So return. And another one is the constraint. Still BCS collector, create edit, and this we want to limit all the movement so the tube won't move. Then okay, so far we have made two component, three load collector, two material, two properties. So everything should be good right now. So it's time to make the set, I think. Okay, we skip the group first, we make the set first. So go to analysis, under entity set. Okay, first of all we're going to make a set for each component. So the box first is the tube, let's say tube S, and the card image is GR rod, and we change the node into component, click component, and it should be the aluminum tube. Okay, aluminum tube should be highlighted, and click select and create. So you have first set of tube S. So next we are going to make the solid box set, which is we call box M for master. Okay, for the box, change this to surf ext. Ext means external. Mean we are going to set the external surface of the solid only. So change to surf external, and the component return. Okay, we don't need to change anything here, just create. Okay, you have tube S and box M here. Return, make another set of. Okay, for the load collector, each load collector need one set of each item, which is, let's put it here, velocity first. Velocity. Change the card image of GN rod. You don't need to create and edit anything yet, just create. Next is we have mass, create, and constraint, create. Okay, so you should have tube, the first one, the box, the surface, velocity, mass, constraint. Okay, just leave everything as default first because we're going to edit the value later. Okay, next thing is we want to create an R body. So go to component, create, change the name to R body. Okay, R body, change the card image into none. Yes, okay, it should have the setting like this. So we are going to make another set for the R body, which is go back to the analysis, entity set, and this time we are going to make the R body inside the solid tube. So let's hide the solid box. We hide the tube first. Okay, nodes, click here. No, not yet. Return first. We are going to make entity set thing. So tube S, box M, velocity, mass. Change this to R body. And create. Oh, no. Okay, delete this R body first. delete. Okay, we are going to make our body at in 1D. Click 1D, we go into rigids and create. Okay, change here into multiple nodes. Click here, multiple nodes, and here is calculated node. Okay, click on the nodes and click one of the at the surface, and click again by collector to box solid. Click OK. Everything should be highlighted and create. Okay, now you have set for the R body. Change this into, change the name to R body. Okay. So what R body mean is that inside the solid box, you can see there is another entity that we can attach the velocity, the mass to the solid box itself. Okay, so you should have 3 colors. Make sure everything is in order, and then now is the time to make the group. You should have 3 component, 3 load collector, 2 material, 2 properties, and 6 set. Okay, so we are good to go. Go to analysis and create interface. We want to crash this tube into this solid steel, so put a name and change the type into type 7 image and create, return. Okay, now to change the setting, expand your group, click add the contact, and then okay, here we are going to change the gr rod slave entity. The slave is going the tube, is going to be the tube. Change the node into set. Since we made the tube S earlier, click the tube S, and the surface ID, go to set. We have the box M, and click OK. So everything is set. You can change the setting here if you want it, but you don't need to change anything, I think, so it's okay. Okay, now we are going to check back all the setting that all the set that we make sure that everything is in order. Tube S is 1 component, box M. Okay, when you go to the box M, you see that the cut image is surface external and the set type is non-order, but we want to change the non-order into formula, so yes. Okay, the setting will change, and right click at the number of clauses, edit, insert, and the entity selection, we are going to select the box solid. Proceed. Okay, so velocity, okay, the entity type is 0 node. This one, since we make the load collector earlier, so we can change this into set. Go to, wait a second. Okay, first the velocity is still nodes, so we want to put this set into the actual real world, so we're going to hide the everything else except for the R body. We're going to attach this velocity to the R body, so we don't need everything else. Just zoom in really close to the center of the R body. Alamak. Okay, go back. Okay, make sure your node is on, and then click the center and proceed. Okay, so everything should be okay. here 1 node. Then let's move on. And the mass also we want to put it at the same with the velocity, because we want to limit the movement of the velocity. So node, zoom first. Center, proceed. Okay, and the constraint. Constraint, we will put it at the tube. So change the view. Okay, we want the constraint to be at the end of the tube here. So click nodes by window, make a box at the end, select entity, and let's see. Okay, we have at the end here. Okay, so now everything is done for the set. Now we are going to change the load collectors. We are going to attach this set to the load collector. First, the velocity, go to the gr0 id and change it to velocity. The mass, attach the gr0 id to the mass. And the constraint, we are going to attach the id to the constraint. Okay. Alright, so everything is done with the setting right now. The only thing that you need to know now is what are you going to export. So what data do you want? So the quickest way to know what data you want to export is through a tiny things called utility BC Manager. Okay, through BC Manager, the program will create a default template for your export output that you want. Okay, click the BC Manager and go. No, not BC Manager. File Engine File Assistant here. So this Engine File Assistant is going to assist you in creating the output that a typical simulation will create. So create engine file. You want termination time of 0.015 and leave everything blank. Tick the generate default input request and click OK. So when you go back to your model, you can see that now we have another column here called cards. This is all the output file that your project will simulate. So you can check everything. Maybe you can change a few of this setting here. So let's see the original setting. Okay, I have already made a blank template. So let's see the setting. Open mod. Okay, let's compare the. So the engine run is 0.015. Okay, close. So NMDT. Okay, copy this value. T file. Time frequency. Change the. Noda. I think Noda is going to be default value. Anim is also default vector. before element, same. Okay, the only thing you can change is the engine run, which engine run means that how long the simulation is going to run, and dt is the frequency of your simulation, and the same with t file also, and the rest is just default. So for this simulation, I think everything, if everything is done correctly, it should load it with no problem. But I'm going to change I'm not going to change yet. Let's try radius first. Okay, I'm going to save my file first. I'm going to make folder here, test crash. Okay, file save as model to my desktop, test crash, save. Okay, so I'm going to try radius. Export option is all, run analysis, and run number 1, just radius. 7 error, we have 7 error. Okay, where is the error? I think it's in the material itself. So let's check with our original material. Okay, we have here aluminium and aluminium. Let's see. Okay, we didn't tick here. Change it to 1, so we can put this sigma y. Okay, from this we have a yield strength of 165 and 260. 260. Right. Yield strength. Sigma y is 125. 0.15. Okay, let's check the steel. Tick the reference row option. 0.2. Okay, everything is fine here. So let's try again. Oh, the contact. This is fine. Okay, now we have 6 arrow now. Okay, let's go back to the component. Okay, here you see that your properties ID, your material is not assigned yet. So right click here, assign, and for the aluminum tube, tube properties and material aluminum. Okay, and for the R body, the solid block, right click, assign, steel properties, and material is steel, apply. Okay, so let's try again. So we have no warning right now, so everything should go as mentioned when the program is running at full capacity. So let's view the result. Okay, let's see. As you can see, there's nothing changed here because the thickness is actually the crash is happening right now. We can see the stress. Okay, the stress is acting with both component right now, but because the aluminum is so thick, the changes is minor. So what we are going to do right now is to stop the simulation first. No, close, and change the thickness of the properties. Tube properties, we change the thickness. If let's say we change the thickness into 0.5 mm or something, then we reduce it. Okay, it should take a while depending on your computer. If you have a wooden PC, it might take longer, but if you have a NASA computer, it is going to be fast. Okay, let's see the simulation. As you can see, let's play. Okay, here you can see it's already taking effect. Okay, depending on the value that you put inside the material, the properties will affect how the simulation is going to be. So you can change the value, play with the value around, and then simulate for your lab report. So thank you, and best of luck for your lab report and your lab test. Thank you. Goodbye.